Okay, hi everyone. Good afternoon and welcome on to today's Introduction to Databricks online workshop. So what is Databricks? I personally use it for work and I thought it's just a platform for distributed computing, mostly for data exploration and training models. But this year, I feel like Databricks really stepped up the game and they created a real full end-to-end development platform from data exploration to production-ready development platform. So today we have with us Deepak, who's a solution architect at Databricks. He holds a number of solution architect certificates, including IBM Cloud, AWS, and Oracle Cloud. He holds 5 patents and 3 IPs. Hi, Deepak. Nice to have you here.
Thanks, Alexandra, and it's a privilege to talk to the IT Brief folks here. Thanks for giving me the opportunity.
Thank you. Before we start, I just want to say that this meeting will be recorded and the recording will be made available on YouTube. I will share the link on IEEE LinkedIn page, and the materials, the presentation will be sent to those who registered after the meeting. So that's all from me for now. So over to you, Deepak.
Thanks, Alexandra. Hello, everyone. Thanks for joining. I'm Deepak, so I'm a solution architect with Databricks based in Brisbane. So I've before Databricks, I was with IBM and Oracle for almost 8 years in total, working in the data and AI space and in the cloud space as solution engineer and solution architect. Right. So today we will take a quick look at Databricks. What Databricks as a platform is, how it started, what it is now, what it is capable of, and who uses Databricks. Right. So we wouldn't need the entire 1.5 hours for this. We would probably trim this down and cover as much as possible. All right. So Databricks is a unified data analytics platform, right? So when I say unified data analytics, we work with 3 different personas: data engineers, data scientists, and data analysts, right? So it started with Apache Spark. The creators of Apache Spark are actually the founders of Databricks, right? And so they started Databricks in 2013, and Spark, it was the de facto standard for big data processing back then, but now it's the de facto standard for data processing in the cloud, right? But Databricks is beyond this Spark execution engine. It has much more to that in the Databricks family. So there are other open source projects like Delta Lake, which is part of the Linux Foundation, and Delta Lake is an open source storage layer which gives you asset transactions on top of your existing data lake files, right? So your data lake could be your AWS-based data lake, or it could be an Azure-based data lake. If you enable Delta on top of it, you will get asset transactions and you'll have better reliability and performance. And then MLflow. MLflow is another open source project which belongs to the Linux Foundation now. So that entirely is focused on machine learning operations. So if you think about CI/CD for machine learning, MLflow takes care of that. So that ranges from creating experiments, running multiple experiments, logging the parameters, metrics, and artifacts of your experiment runs, comparing your runs, picking up the best model, best hyperparameter, distributing your hyperparameter tuning, and finally, once you have your best model, deploying the model, and moving it from development to staging to prod with workflows and approvals in place, and finally, serving your model as a REST API or as a batch prediction. All this is taken care of by MLflow. So it's a pure MLOps framework and open source. And finally, Redash. So Redash was recently acquired by Databricks, and Redash is another open source visualization tool and a SQL editor. So, you will be able to write SQL queries, browse your schemas, and then create visualizations and dashboards with query histories and alert capabilities. So that is also part of the Databricks family now. So as you see here, you would have got a pretty high level overview now itself, because we deal with data engineers and who work with Spark and Delta Lake, and we deal with data scientists who work with Delta Lake and MLflow, and we deal with data analysts, SQL analysts who work with Redash and Delta Lake, right? So that's how the platform is composed of. And we work with companies across the globe and across the industries as well, and be it 100-year-old companies like Betchel, or major manufacturing companies like Shell, and we also work with a lot of digital native companies as well. Right. So why is Databricks so important, and why are many customers using us now? Well, when you look at companies, what Databricks does is it actually helps unlock business value. And how do you unlock business value is when you combine machine learning and analytics, and when you have capability to use as much as data possible and combine it with machine learning and analytics. But most of the organizations are failing to get business value now because of three main reasons. One is data silos, and the other one is technology silo and people silos, right? So talking about data silos, when you go to an organization and you ask about the data estate, they'll have streaming data sources, they'll have data lakes, they'll have data warehouses, lots of application databases, NoSQL data stores. This data estate is fragmented, so data is everywhere. And then they also will have technology silos, right? So each business team will have their own tool set of choice. And based on the data source that you have, you might choose a preferred tool set. So there'll be many tools spread across different teams, which creates this technology silo as well. And likewise, data scientists will have their own preferred way of doing, data science work. It could be an account environment or a virtual machine or an RStudio environment or a Jupyter Lab environment. So that again is a personal choice that data scientists will have. And when you finally go to deployment, you'll have to choose between Azure ML or SageMaker, or you'll have to, if it's the BI use case, then there'll be other tools like Tableau or Power BI. So you see, the tool sets spread across, and data sets, the data is spread across as well. So it's kind of fragmented. So this is what Databricks is trying to address, right? So in order to unlock business value, there are 4 key challenges that we are trying to address. The first thing is data being messy, siloed, and slow because of the fragmented data estate I was talking about. The second thing is ML is hard, and productionizing ML is even harder, right? So, that actually is because of the people silo that exists, where data engineers work in their own tool sets and silo, and data scientists work in their own tool sets, right? And the third thing is BI being limited to a fraction of data, right? BI by design was schema on write. So you're just limited to what was written into a data warehouse, and you were only able to use that. So you're always limited to a fraction of data. So that's another big challenge. And finally, you need a platform which is enterprise ready. You need to be able to govern the platform. You need to have better reliability and have good security as well. So looking at the first challenge, how do we address that? Well, organizations are building data lakes now, right? So it could be in Azure or AWS. So you can use the same data lake, bring all your data there, be it your business data, your application data, or your streaming data. Everything can come to your data lake, and then you use Delta Lake on top of it, which gives you reliability and performance by having this asset transaction capability. It gives you transaction log. And finally, we have Delta Engine, which has compatibility with Spark APIs. It is a high performance query engine, which you can use for your BI reporting use cases, or you can use the Databricks runtime and MLflow for your machine learning as well, and fetch your data out of your data lake, right? So what you're doing here is you're making all your data available and ready for analytics. So once you have your data in Delta Lake, right? So which is, the data still sits in your data lake, and you have the storage layer with Delta. The benefit here is if you have data science teams building machine learning workloads, they then can consume the data out of Delta Lake and then use Databricks runtime for ML, which is a prepackaged runtime with most of the common frameworks used in the industry for machine learning. That could range from TensorFlow to PyTorch to Keras to Spark, to XGBoost. So all these frameworks have been packaged together in this runtime, and it's ready to use. Imagine, if you have to spin up an instance and set this up, this is kind of risky in the open source world, right? Because you will have to keep your packages up to date. If there is a new package, you'll have to update that. If there is a security vulnerability, you will have to patch it up. You'll have to fix it. So there's a lot of operational work involved here. So Databricks takes all that out of you. So we are going to manage this runtime, and we are giving all these packages readily available for you to use. All you need to do is just consume, right? So that's Databricks for runtime for ML. And once you start to consume, you can build your models, within notebooks. And the Databricks notebooks are actually polyglot, so you can use Python or R or Scala or even SQL to do your work, right? And along that, you can use ML Flow to track your models, log your parameters and metrics, compare your models, and finally, when you have your best model, deploy it uh, and move it across to staging and prod using workflows. So all this is possible with ML Flow. And now, talking about BI being limited to a fraction of data, that is because of the schema on write nature, right? But coming to the data lake world, you can use various data sources, bring all your data to data lake, and enable Delta on top of it, which means, for your structured sources or your semi-structured sources, you can parse it and store it in a Delta format. And for your unstructured sources, your data still sits in your data lake. And then you can combine all these, for all your use cases. But specific to BI, you have massive amounts of data that's available, and you're not restricting to a specific use case or a specific business need here, right? You have all the data available in your data lake. So then you can use Delta Engine to query the data and use your BI tool of choice, be it Tableau or Power BI or Redash that comes part of Databricks, to build your dashboards and reports, right? So here you're actually, you have the capability to use massive amounts of data, and you're not just restricted to less amount of data here. And finally, you need an enterprise, enterprise grade platform. So Databricks is an enterprise cloud service. It integrates well with Okta and Active Directory, and it also has various security postures within the platform that you can turn on, and we're compliant for HIPAA, PCI DSS, FedRAMP, and there is it's GDPR ready, and it's ISO certified as well. So it is a true enterprise cloud service. So to summarize that, what is this all about? So you can bring all your data to your data lake, use the cheap storage, the cloud storage, which is scalable, and you pay less cost, store all your data there, have the structured transaction layer on top of your data that is stored in your data lake, which gives you asset transactions, reliability, and performance. And then use Delta Engine, which is a high performance query engine for your BI use cases. Use that to build your BI reports and dashboards, or use that for your data science works, use cases to build your machine learning models. So this is like a true one platform for every use case here. And you can see, when you compare this to the fragmented data estate and tool estate that I was showing you before, you're pretty much bringing like 10 tools or 10 different data estates into just one good platform, and you're serving multiple use cases from within that. And there is a new paradigm called lakehouse, right? What is this? So when you look at you know the two different data estates that are currently being used. One is data warehouses, which has a 40 years legacy, and that is designed for BI and reports. So you need to do your data modeling, build your data warehouses, and then you can build some BI and reports on that. And then for the last 15 or 20 years, we've been seeing data lakes being built where you can store structured, semi-structured, or unstructured data, and then you can do machine learning on top of raw data or use ETL, and then extract data out of your data lake and put it in a data warehouse for your reporting purposes. So this was things that were existing in parallel, but it is not desirable. You don't need two data estates for for just achieving two use cases, right? You can have all in one, and that is what this lakehouse concept is. So this is to unify data lake and data warehouses together so that you can have all your data in data lake and then use that for various use cases ranging from streaming analytics to BI to data science to machine learning. So Databricks actually enables that with Delta Lake and Delta Engine. Right. So data analysts actually a part of the business, and they are in many parts of the organization, right? Could be of sales or marketing or finance or HR. They prefer SQL as a default language to query the data because they're comfortable doing that, right? So if you want data teams to unite, then we have to make it easier for them to consume data. And that's what the is the acquisition of Redash is about, because we want SQL analysts to have a good home in Databricks, and they need to be familiar with the tool sets they're using, that they're used to, and they should feel comfortable doing the same in Databricks. So Redash was actually acquired to do exactly that. So Redash has about 7,000 plus open source deployments across the globe. There are like 600 plus customers, and Australian customers like Atlassian also use Redash in the product. So as I said before, Redash has joined Databricks and it's part of the Databricks family now. What does it look like, right? So this is the query editor in Redash. So you can browse your schema and you can create query snippets. You can schedule your queries and have alerts in place, similar to any other SQL query editor you've seen before. And within the query editor, you'll be able to create visualizations as well. And then once you create visualizations, you can add your visualizations into a dashboard and create dashboards and reports and publish your dashboards as well, right? So this is what Redash is about. On top of this, you also have query history and alerting capabilities as well. And yeah, you can natively connect to Databricks within Redash, or you could also have connectors to various other data sources. You can bring all your data into Redash and then build some reports. Yeah, so we have spoken about Spark, we've spoken about Delta Lake, MLflow, and Redash. There are other open source projects that Databricks contributes to as well. One interesting project is Koalas, right? So Koalas, is like a Pandas API, but it has a Spark execution engine in the background. So if you have ever used Pandas, which is a data manipulation, API, a framework available, where you do a lot of, especially in the data science world, Pandas is predominantly used to actually, transform data, work, prepare your data, do feature engineering. But Pandas is actually restricted to a single node, right? So you cannot scale beyond a single node using Pandas. So if you use, for example, data sets that is greater than 10 gig, if you want to load everything into memory and do some operation on that, Pandas will not be able to do that for you. So Koalas is built for that. You can process massive amounts of data and distribute it across the Spark cluster, right? So you can have 10 workers, working to actually process your data, but the APIs that you're using will be compatible with Pandas APIs, right? So that's what Koalas is about, using Spark execution engine for your pandas workloads. Right. So there are other projects, as well, like HyperOpt, which is like a distributed hyperparameter tuning. So if you wanted to do hyperparameter tuning on a massive scale, so HyperOpt is a Bayesian approach to do distributed hyperparameter tuning. And using Spark trails, you can distribute it across the Spark cluster. So you can do like massive amounts of hyperparameter tuning in fraction of time. And being a Bayesian approach, it's much faster than your grid search. Sometimes your random search as well. Right. So Databricks is part of two clouds as of now with Azure. It's a first-party service, so you can integrate with other Azure services. Like you can trigger Databricks from Data Factory. You can connect it to ADLS Gen 2. You can consume data from Event Hub. You're streaming data. You can push data out to Cosmos, which is an operational store, and you can use Azure DevOps for your pipelines, for your um, Azure DevOps for your notebook integration, and then have Power BI on top of Azure Databricks to build your reports, enterprise reports. And similarly on AWS, you can use S3 as your data source, as a data lake, consume data from Kinesis, your streaming sources, have Redshift in place. If you can consume data from Redshift as well and store in Delta. And then when you want an operational store, you might as well choose Dynamo, which is an operational store in AWS. Right. So that's what I had for the overview. I'll just pause to see if there are any questions before I jump on to a demo of the platform. So I'll open up for any questions now.
Are there any questions? You can ask, either unmute yourself or write in the chat. Considering there are only a few of us attending, I think it's fine if you just unmute if you want to ask something.
Mm-hmm.
Well, if not, let's continue with the demo.
Sure. Okay, so let me move on to this demo. So this one is a community edition of Databricks. So community edition is a free edition that is available for anyone to try Databricks, right? So if you really wanted to, try out community edition, where does it just hide floating map? Okay, there you go. So all you need to do is try Databricks. Yeah, and you can just fill in your details with your email ID and then sign up, and you'll get a link to the community edition. So all you need to do is then log on to community.cloud.databricks.com with your email ID and password, and you should be able to come to this place to try it out. So with community edition, you have the capability to create a cluster, but the cluster will be available only for 2 hours. If it's idle for more than 2 hours, it will shut it down. But if you keep using, you can keep using as long as you want, right? But this is like a much scaled down version of what you can do than what's possible in the enterprise version, right? So I'll give you a quick platform overview. And just a second, I hope this loads. There you go. Okay, so what does a Databricks platform comprise of? This is a landing zone, right? Once you come here, you'll have all your common tasks. You can create a notebook, cluster, experiment, all this with the shortcuts. You can access all your recents here, and every fortnightly release that we have, what we release, will have a release note here, so you can see all the updates. The Databricks platform is actually segmented into 3 main sections. One is data. Then you have a computer environment where you can run your code, and then you need a place to actually write your code, right? So that's workspace. So data, compute, and workspace. So compute in the Databricks world is called cluster. right? So first thing is data. So we have an internal metastore here. So you can create all your databases, schemas, and tables, and log your tables here with the internal metastore. So you can browse your metastore and then use that for your work, within the notebooks. You can add, upload, drag and drop, bring your own file and store within the Databricks as well. You can consume data from S3 if you already have data, or it could be your ADLS as well in Azure. And we have also other connectors available. So this one, what I'm showing you is the AWS version of Databricks. If you look at the Azure version, you will have different set of connectors there. You'll have connectors to event hubs and SQL DB. So you have all these connectors available that you can use readily. So that's data. And the second thing is cluster. So cluster is a Spark cluster that you need to actually execute your workloads, right? Or run your workload, right? So all you need to do is give a custom name, choose a version of runtime that you want, and your version depends on what Spark version and Scala version you want to use. And whenever you see this tag called ML or genomics, that means that, popular packages that are used in the ML world or genomics world are actually already available in those runtimes, right? So it's readily available for you to use. And you can choose to have an auto scaling cluster. So when you enable auto scaling, you can choose the minimum and the maximum worker based on the size of your workload actually, and then choose a specific, image and EC2 shape or a virtual machine shape in Azure. So that actually contributes the amount of cores and the memory you have per node. And finally, if you are into cost saving, you can use Spot instances as well. So Spot instances are available at a discount price. If the demand is less, this is an AWS feature. So you can choose a mix between the on-demand and Spot. So here I'm telling that, between my 5 workers, I want 3 on-demand and 2 Spot. But if the 2 Spot instances are not available, I'm okay to fall back to on-demand, which means it will still have your 5 nodes, if your Spot instances are not available. And finally, you can say that, okay, for my Spot instance, I'm willing to pay 50% of my on-demand price. So if your Spot instances are available, and if it's $1, per hour for these node types, then technically every hour you're saving like 50 cents into 2, which is $1 every hour. I mean, this is just a simple math that I wanted to highlight here. So once you create a cluster, you'll have your clusters available. So you can see there are 3 clusters running now. You can have as many clusters as you want in a workspace. There is a specific limit as well, that you may hit if you create lots of clusters. And finally, you will need workspaces where you actually need to write your code, right? So that's what this workspace is. So if you onboard multiple users on your platform, each user will have their own folder, and within that they can create their own subfolders and their notebooks as well. And they can also control who accesses what using permissions. So you can say this user in this group can read or write or manage this particular notebook or this particular folder, right? So this is what a notebook looks like. Oh, sorry about that. There you go. This one, yeah. So Databricks notebook is actually a polyglot notebook. So though my default language is Python, you can choose any other default language, but within a notebook, you will be able to use other languages as well. So my default language is Python, but if you see, I've used Scala here, I've used SQL here, and I've used R here. So within the same notebook, you can interoperate between languages, right? So, right. So what else do we have? So you'll have to attach a notebook to a cluster for you to execute that. So this is called a cell within a notebook. If you ever used a Jupyter notebook environment, you should probably be familiar with this one. And we have something called a Databricks file system. This is like a few small point for you to interact with your blob stores or your S3 buckets. So you can say, you can mount your object storage buckets here, and then have file system level interaction with your buckets. So you can see I've listed all my folders in my mount, and you can see all the folders there. So what I'm going to now show you is how does a streaming query work. So what I'm doing here is I'm creating a temporary view called reviews. This is out of a test data from Amazon. So this is the reviews data when customer reviews a particular product. And I'm creating a streaming query here in Scala. And I'm telling that trigger one file every second, and give me visualization where I want to show the brand and group the brand by count and order by descending. So this is my query, and this is a streaming query on my data set. So imagine if you're consuming data from Kinesis or Event Hub or IoT Hub, or Kafka, you can build these streaming dashboards in a similar fashion, right? You can like have a real-time or near real-time dashboard based on this. So whenever you say this keyword called read stream, that is when Spark considers this as a streaming job. And you can see this cartoon here actually means that this is a streaming job. So you can see that it will trigger one file every second, and your data visualization should actually keep changing. There you go. So that's streaming. Right, so let me cancel that now. Now I'm going to show you how do you run some simple SQL. So within the same reviews, data, now I'm, grouping the rating and doing a count on that. So you can just write simple Spark SQL on top of your data set here as well. And Databricks notebooks also have embedded visualizations out of the box. So you can choose, with the visualizations available here, and you can build your visualizations. If the inbuilt visualizations are not enough, then you can bring in your own third-party visualization tools like Matplotlib or D3 or Seaborn, and have your beautiful visualizations up and running. So that's what I'm going to show here. I'm using R here, and I'm creating a word cloud here, right? So using this R package. So this is a third-party visualization capability that just wanted to show you that it's possible to do that within Databricks. So you can do machine learning with Databricks, right? So because this is using Spark, what I'm doing here is I'm creating a pipeline, and my pipeline has a series of stages, right? So I'm building a logistic regression model on the same reviews data set, and I'm fitting the model to my training data, and I'm doing some predictions on my test data, and I'm creating a final temporary view called temp predictions here, right? So this is just to predict the ratings for these brands. So with Spark ML, you can see this is using PySpark ML, which means you're building machine learning in a distributed fashion using Spark, but you can also use sklearn or PyTorch or any other like TensorFlow. All you can use all this to also build your models here, right? So my model is built. Let me look at the training data, and this is what my training data looks like, and it has a review and it has a rating. And finally, let us look at our predictions, right? So yeah, so this is a label, this is a prediction, and this then shows the probability as well for that particular prediction. There you go. So one feature that I didn't show you is you can also do graph processing, using Spark, which using graph frames, you'll be able to build relationship models and also do things like page rank using graph processing as well. So that is also another Spark feature. So that's Databricks platform, right? So I'll just stop here and take any questions if you have. Uh,
Deepak, can you maybe show the display functionality, how you can alter the graph? Because I found it very quite powerful way to visualize the data frames very quickly. And I know that you can alter the graphs depending what you want to see in data.
yeah, this one?
Yeah. Yeah, so you can choose what you want to plot, how you want your plot to look like. It can be bar graph or line chart, scatter plot. Yeah, pie chart. So yeah, I found it really cool.
Yeah, these are all embedded. I mean, makes it really easy for you to do some exploratory data analytics and also build some basic dashboards. But one thing that I probably missed to show is, the Databricks notebooks are collaborative, right? So you can have multiple users access the same notebook at the same time. So if you ever used Google Docs, where you see multiple colored icons at the top, indicating who's using what. So Databricks also will do that. You'll have multiple colored icons, telling who are all using the same notebook, and then you can add comments, right? So you can add comments to say review whatever, right? And people can add comments and collaborate together in a team and work collaboratively within the Databricks notebook. And you also have embedded visualizations within, embedded dashboards, like basic dashboards that you can build within Databricks notebook. So if you have some good visualizations that you have built in a notebook, you can just add that all together in a dashboard, and you can finally present your dashboard to a specific team and just share this URL, and they'll be able to update this and then have this dashboard presented. This is like a basic dashboard, and this is getting served out of a notebook, right? So if you want anything a bit more sophisticated than this one, and that's when you go and use Redash or your BI tool of choice like Power BI or Tableau. So let me give you a quick view of Redash. So this is what Redash looks like, right? So Redash, again, as I said, is a SQL query data and visualization tool. So you will be able to, build queries, browse your schemas and tables, write queries, and then, so if I do like a select star from Deepak demo db dot gold loan status, right? So you can build your queries here. And once you have your queries, you can build visualizations here and then add your visualizations to dashboards. So now I have my query, which has a state and a count for each state in US. I can add a visualization. I can say that my visualization needs to be a map. Okay, where is that? Yeah, so that's enough. Oops, sorry. Yeah, I mean, so you get the idea here, right? So you'll be able to create a visualization here, and then plot your data accordingly. So once you have your visualizations built, you can add your visualizations to your dashboards and build your dashboards as well, right? And you can have parameters for your dashboards, and you can even publish your dashboards and set a refresh schedule and share your dashboards. On top of this, you will also have query history. Query history is to say who is using what and what endpoints are they using. how long are the queries are taking, and some stats on your queries as well. If you want to do some optimization on your queries, that's possible. And finally, you will be able to create alerts as well. You can create alerts and plug in a query and then schedule an alert for that query. So that's Redash.
So it will automatically contain all of the tables that you have in your Databricks?
That's right. So you'll have to create an endpoint for that. Once you have an endpoint, that endpoint will then be able to, you can use that endpoint to actually browse your schema.
Right, cool. And regarding collaboration, you can also version and use GitHub for notebook versioning, right?
That's right. So thanks for pointing that out. So yeah, we have a revision history. By default, you will have a revision history as well. So you can roll back to a particular revision, particular version, and you can also, link it to your, GitHub repository or Azure DevOps, and then, push all your notebooks to there as well.
Cool, thank you for that. Are there any questions?
Right. There's something in the chat. Question regarding access control. How to administer other users? Thanks, Mark. Feel free to unmute and ask if you wanted to. So there are ways in which you can do that, right? So let me log into a platform where I have access. So you can onboard users. If it's an Azure Databricks instance, you can say you can do a SCIM replication. So it's a cross identity management. You can do that replication using SCIM, which means your users and groups will be replicated. If you're having your users and groups in your AD, it will automatically be replicated here, and then you can control who is an admin, who can create cluster, and then you can create groups and add entitlements to the groups. So I can create a group called user, and I can add an entitlement telling they can create cluster or not. I can even have nested groups as well within parents. And so this is to actually organize your users and groups and control who is an admin and who can do cluster creation or not, right? And finally, when you create your clusters, you can also say who can attach to a specific cluster, who can manage a cluster, right? So when you say attach to, it means that they can only use the cluster. They will not be able to start or stop a cluster. They can start a cluster, but they cannot stop a cluster or restart a cluster. When you say manage, they'll be able to do everything. They're like admins, right? So this is like cluster access control. And finally, so with regards to workspace, you still have workspace access control. You can say who can read what, who can run what, who can manage what. This is at the workspace folder level or at the file level. And you also have data access control, which is called table access control. If you have ever issued like a grant statement in a SQL world to say grant select on the schema or grant select on this table, you can do that as well. You can say, okay, I want users to only select schema A. I want group B to only read table B in schema B. You can do all those controls here as well using table access control.
Can you also please mention scheduling of the jobs, just to show people that they can really use Databricks for the full ML production, whether it's for streaming or batch processing?
Sure.
Full ML project can run in Databricks.
Sure. There are two types of clusters, right? So there is an all-purpose cluster, which is like an interactive cluster for your interactive workloads or exploratory data science, or for your dev work, you can use interactive clusters. And then when you want to productionize your work, you can schedule a particular notebook, right? So for example, if I have to right? I'll just open this one. So if I have to schedule this notebook and I want to run it in a scheduled fashion, I'll say, okay, schedule this as a job, and then run this every 2 hours starting this time. You can choose UTC plus 10, which is Brisbane, or whatever the time is, and then click OK. So what it'll do is it'll create a new schedule for this job, and there you go. So you can see that it creates a schedule, and then when it is running, it'll create a specific job cluster here, right? So job cluster are like ad hoc clusters created only for the execution of that particular job, and then once the job executes, the cluster shuts down, right? So you only pay for your execution time here. You don't need an always running cluster, right? So this job, you can submit jobs via APIs. You can submit jobs from ADF, which is your data factory, or you can schedule a notebook within Databricks as well and run it as a job.
Thank you. Are there any other questions? What can you share from what you showed us today? I think you can share the presentation.
Yep, I'll share the presentation.
Yeah.
Yeah. So I might as well, share a particular link, so where you can download some sample notebooks,
Awesome.
right across in Community Edition. Let me do that now. Just a second. So I'll stop sharing now. I'll probably send that in the chat window. So where is that? Just a second. There you go. Yeah, if you go to this link, that I'm sharing in the chat window, you'll be able to download a DBC file, which is a Databricks cloud file. It'll have two notebooks, one for data engineering and one for data science. And it will tell you, how do you create delta tables, how do you create the bronze, silver, gold delta tables, create some simple ETL pipelines, create a simple streaming job. And then at the data science notebook, it'll tell you how do you create model, how do you use ML flow tracking, experiments and all that. So just really good things to try out in the community edition. So
yeah,
let's use this in the community edition.
So yeah, you can go to the link, and you can actually import directly from a link, right, into your workspace.
Yeah. So if you go to this is a Bitly link, so it's a short URL. So you can download this DBC archive, and you just
Okay, so you have to download it and import.
You just drag and drop to the DBC file and import it.
Right. Perfect. So I hope everyone's will go and try this and give a community version of Databricks a go. And hopefully you can see that Databricks can really be used for full development lifecycle, whether it's for data ingestion and exploration and visualization, or for your ML projects.
Yeah.
If there are no more questions, I think we'll wrap up.
Yeah, just one last thing before I wrap up. I'm sending you another link as well in the chat window. So we have our Data and AI Summit coming up. So this is formally called Spark and AI Summit. So this is running from the 17th to the 19th of November. So there are multiple sessions, new features that are going to come up in the Databricks platform. What are customers doing? How are they building pipelines? How are they architecting, in the Azure or AWS world? Multiple sessions, very useful sessions. You will also learn a lot about Lakehouse. What is Lakehouse? What is Databricks vision on that? So yeah, if you have some spare time on those 2 days or 3 days, you can just tune into a couple of sessions, interesting ones, and hear from people on the ground. So I've shared that link as well in the chat window.
Awesome, thank you. I will also share that link on our IEEE LinkedIn page.
Perfect. Thank you.
Thank you, everyone. This was last event for IEEE Computational Intelligence chapter for this year, but there will be more coming next year. There are also some volunteering positions open. Even though the election's officially finished, we're still collecting expressions of interest for next year. So if you're interested in volunteering for IEEE, please reach out to me. And this brings us to the end of today's workshop. Thank you so much, Deepak, for your time. And thank you, everyone, for joining.
Thanks, guys. Good talking to you. Have a good one.
Yeah, have a great of the rest of the night. See ya.
See you guys. Bye.
Bye.